Hello, this is a review of Unit 1 for Pre-Algebra. We are going to be reviewing real numbers, which is what Unit 1 is all about. We're going to talk about fractions to decimals, decimals to fractions, repeating decimals, classifying numbers by type, estimating square roots, and ordering numbers in different forms on a number line. We also need to explain why a number is rational or irrational. It's not enough just to be able to determine whether it is or is not rational. You do need to explain why it is, or why it is rational, or why it is irrational. Okay, here we have fractions to decimals. To convert a fraction to decimal, what you need to do is you need to take the bottom number, the denominator, and find out how many times it goes into the numerator. Since 5 does not go into 3 at all, we put a decimal point next to it, add a 0 on the end. 5 does go into 30 6 times. 6 times 5 is 30. When we subtract that, we get no remainder, so we have found the final decimal. 3/5 is equal to 0.6. All right, now we'll do the same thing with the next example here. We take the 3, find out how many times it goes into the 2. It doesn't go into 2 at all, so I put a 0 there, bring up the decimal. 3 goes into 20 6 times. 6 times 3 is 18. Subtract that, I get 2 left over. Put in another 0, bring it down. 3 goes into 20 6 times. 6 times 3 is, wait a minute, this looks familiar. Isn't that what I just did? Yeah, it turns out this is going to be a repeating decimal. It's going to keep going 6, 6, 6, dot, 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 all like that. So to write that, to show that it's repeating, I would write 0.6 with a line on the top to show that I've got a repeating 6. Okay, now let's talk about decimals to fractions. To convert decimals to fractions, this place value, the first place value is the tenths. The second place value is the hundredths. The third place value would be the thousands. The fourth place value would be the 10,000ths. So it makes sense when you are writing them that you are going to write the number that's there, the 8, without the decimal, and put it over a 1 with as many zeros as there are place values. Because remember, this is the tenths place value, so this is now 8/10. Once you've done that, you do need to simplify, because when you are asked to find the fraction, you do need to simplify the fraction. Now, both of these are divisible by 2. So I divide them both by 2, and I get 4/5, which is your final answer on that question. Next one, I would put 75 over 1 with 2 zeros, because there are 2 place values here. And this is the hundredths place value that it's worked out to. Both of those are divisible by 25, which is going to give me 3 over 4. 3/4 for my final answer on that one. The last one here, we have 1, 2, 3, 4 place values. So we're going to take that number without the decimal point. Notice how I don't include those leading zeros. They're not going to mean anything in front of the 37 here. But I am going to put 4 zeros on the bottom, because although they mean nothing up here, they do mean something down here. So 4 place values, 4 zeros. I have 37 over 10,000. And that cannot be simplified, so that is your final answer there. All right. Okay, now when you've got repeating decimals to fractions, it's important to remember the backwards way here. Let's take a moment. We're going to look, although we do want to find out what this is as a fraction, what this is as a fraction, what this is as a fraction. We're going to take a moment to show, I want to take a moment to show you that when I go 9 goes into 1, I do a point 0, 0, 9 goes into 10 once. 1 times 9 is 9. I subtract that, I get 1 left over. Put another 0. I'm going to get that repeating. I'm going to keep having 1, 1, 1, 1, 1, 1, 1. So 1/9 is equal to 1/9 is going to be equal to 0.1 repeating. So it should turn out that this 0.5 repeating is 5/9. Now let's see. Well, the way we do this is, if you think about it, the first thing you would have done if it was just the 0.5 is you would have put the 5 over a 10. But that would be just plain 0.5, not 0.555555555. So since this number, since the fraction there, the decimal, is a little bit larger than 0.5, 0.5 repeating is larger than 0.5, but it does have a 5 here, we need to make the bottom number smaller to make the overall fraction. We need to make this denominator smaller to make this overall fraction larger in value. We don't want to make it smaller by much, so we're going to make it smaller by 1. So we end up putting a 5 over 9. One way to think about this is to think of the line on top of the 5 as a lazy 1, and then you have to account for that lazy 1 by subtracting 1 from the denominator, which is going to give you that 5/9. Now, the same thing could work for the two-place values, the hundredths. We're going to take that 27. You would put it over 100 if it was just 0.27, but that repeating part, we're going to get rid of the lazy 1 from on top here. Get rid of that lazy 1 by subtracting 1 from the denominator. And that's going to give us 27 over 99. Now, in this case, this can be reduced because 27 and 99 both have a common factor of 9. So I end up with 3 over 11. So that's our final answer for those two. Next one, we have 3 decimal places. Well, with 1 decimal place, it was over 9. 2 decimal places, it was over 99. 3 decimal places is going to be over, that's right, 999. So it's 1 over 999. And that cannot be simplified, so that is your final answer on that repeating decimal to a fraction. Okay, one of the things you're going to need to know for the test on unit 1 here is all the categories of numbers. Natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. These are all the vocabulary here. We should know that natural numbers are like the counting numbers, 1, 2, 3, 4, 5, 6, ... like that. That is what comprises the natural numbers. It does keep going up to infinity. Whole numbers are all the natural numbers. That's why the whole number circle, it goes around the natural number circle, are going to be all of those natural numbers plus the number 0. That's the extra whole in the whole number. Okay, then we're going to go to the next step up. The next step up is integers. Integers includes all the whole numbers, all the natural numbers, and the opposites of the natural numbers. The opposites would be the negative values. So it would be -1, -2, -3, and so on like that. So integers includes all whole numbers, all natural numbers. Rational numbers is any number that can be expressed as a fraction, a over b, where a and b are both integers, and b is not equal to 0. B cannot be equal to 0, because if it's equal to 0, then you're dividing by 0 here, which means that that is not real. You can't divide by 0, so it's not a real number. Then you have irrational numbers. Irrational numbers have non-terminating, non-repeating decimal values. And we should be able to recognize that the square root of a non-perfect square The square root of a non-perfect square will result in an irrational number. So that will become irrational. All right. And above all of this, you have real numbers. Real numbers is this whole box. Everything in here is a real number. Irrational, rational, integers, whole, natural. This encompasses everything. So even irrational numbers are real numbers. All of these are real numbers. What is not a real number? Well, technically, you don't need to know it for this grade level, but if you have the square root of a -1, that is what's known as imaginary numbers. When you're working with a square root of a negative like that, you're talking about imaginary numbers. But that, again, is not necessary for this grade level. The last slide, I mentioned perfect squares. Now, we need to memorize those perfect squares. The definition of a perfect square is when you would take the square root of that number, the result is a whole number. It's a whole number. So when I take the square root of 4, I would get 2. Square root of 9, I get 3. Square root of 16, I would get 4. Notice how these are counting upwards. That's the best way to memorize these perfect squares. Count up. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. And so on. This down here ends up being 15 times 15. Gives you that 225. And the square root of 225 is 15. You will want to memorize at least up to this level here. You may also want to memorize that the square root of 625 is 25, because they love to use that number on standardized test questions. Okay, let's talk about categorizing numbers. When you're asked to name the types of numbers that this would belong to, or number sets it belongs to, here we're talking about the number 5, and we're asked which of the number sets it belongs to. Well, it is a natural number. It's one of those counting numbers that you first worked with. It's also a whole number. It's also an integer. It's also rational because it can be expressed as a fraction, 5 over 1. A and B are both integers. A and B are both integers here, and B is not equal to 0, so it is a rational number. It is not irrational, but it is a real number. So this number 5 is all of these. Let's take a look at a few other examples. 1/2, that is not a natural number because natural numbers are counting numbers. Whole is not a whole number, is not an integer. However, it is a rational number. It is rational because A over B. There we go. A over B, where A and B are both integers and B is not 0. It is also a real number. So this one is just rational and real. -3 is not natural. It's not whole, but it is an integer. It is rational because it can be expressed as a fraction by putting it over 1, and it's also real. -4.25, that is not natural, it's not whole, it's not an integer because of the decimal here, but it is a rational number and it is real. Here we have another fraction that is expressed as A over B, where B is not equal to 0, it's actually equal to 3. But when you convert this to a decimal, as we saw earlier, you end up getting 0.6 repeating, which means it is never ending. If it is never ending or non-terminating, that does not qualify it automatically as irrational. In fact, this is not irrational. Why? Because it repeats and because it can be written as a fraction. Okay? So, what is this number? This number is a rational number and it is real. Okay, here we have the square root of 16, which when you simplify this, the square root of 16 is equal to 4, because 16 is a perfect square. 4 is a natural number. It's a whole number. It's an integer. It's rational. It is not irrational, but it is real. Don't assume that all square roots, don't assume that just because you see the square root symbol that it's going to be irrational. Only the square roots of non-perfect squares are irrational. When you got the square root of a perfect square like this, it ends up being everything but irrational. Here we have the square root of a negative. Now, you know we can't do a square root of a negative. So this one's kind of a trick question. It's none of these things. It is not any of these. It is an imaginary number. And yes, mathematicians are crazy enough to actually work with things called imaginary numbers. Square root of 14, that's going to end up being a never-ending, never-repeating decimal. It is somewhere between the values of the square root of 9 and the square root of 16. Because this is a perfect square, this is a perfect square. So the square root of 14 is going to end up being between 3 and 4, but it is going to end up being this never-ending, never-repeating decimal. It is also real because even the irrational numbers are real numbers. Okay, here we are, we're talking about ordering real numbers. Here's 4 numbers here, and we are asked to put them in order from least to greatest. Well, the first thing we should do, we should notice that the negative numbers are always going to be smaller than any positive number. So although the 4 here is pretty close in value to these others, it's going to be the smallest because it is negative. Now, 18 over 4, that's going to be simplified to 4.5, which actually is less than 4.56. If you do, the 4 goes into 18. 4 goes into 18 4 times. 2 left over. Put a 0, 0. 4 goes into 25 times. You end up with 4.5, which is why the next one up is going to be 18 over 4. Compare based on the decimal value. So you're going to need to convert whatever you have to decimals so that you can do the comparison. Now, converting this to a decimal, you would have, well, the square root of 16 is equal to 4. The square root of 25 is equal to 5. So the square root of 17 is going to be pretty close to 4. It's probably going to end up being something like 4.1, which is why the square root of 17 is actually going to come before the 4.5 that is the 18 over 4. Then the 4.56 comes to the end here like this. And this is your final ordered set of numbers. All right, I hope this review was helpful. I'll see you in class.